My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 582. In this lecture, we will try to understand how to train multi-layer perceptron. We have learned lots of concepts. Let's summarize all of the concepts. If you want to train a multi-layer perceptron, these are the steps you should follow. This is like a summary of lots of concepts we learned till now. First and foremost one is, please do not forget to pre-process the data. And one of the most important step in the pre-processing of data is data normalization. If you don't normalize your data, everything will goes into dustbin. This is most important step. This is step number 1. Step number 2, as far as your weight initialization is concerned, please use Xavier or Glorat initialization if you are using sigmoid or tanh activation units. Use Hay initialization if you are using ReLU activation unit. Third option is initialize all your weights come from Gaussian distribution with the small variance. Small variance means I can say it's a reasonable variance. Reasonable variance means what? Reasonable variance means it is not too small, it's not too big, isn't it? Yes, this is step number 2. What is my step number 3? Choose the right activation function. ReLU is one of the good activation functions, and variations of ReLU are also popular. Just refer my lecture on ReLU activation units. This is step number 3. Step number 4, you should try to add batch normalization, especially for deep multi-layer perceptrons, especially for latter layers which are close to the output layer, isn't it? It helps you faster convergence. And also you should look for dropouts. Yes, you should look for dropouts. Dropout is one of the best regularization strategy. It is a very, very interesting strategy. You should always use dropouts. Of course, dropout has a dropout rate, which is a hyperparameter that we have to look at, isn't it? That is step number 4. What is my step number 5? The next thing is what optimizer you choose. My favorite optimizer is Adam, because Adam is adaptive, very, very fast, and it has very few drawbacks. Adam is one of the best optimizer. That is step number 5. Step number 6, what are all the hyperparameters? One of the big problem with deep learning is there are lots of hyperparameters. What is the architecture? An architecture will mean how many layers. Architecture means how many layers should you have, how many neurons you should have in each layer, isn't it? If you are using Adam, what is not only that one, you must not only number of layers, not only number of neurons, you must also what is the dropout rate, isn't it? That is also comes under architecture. If you are using Adam, what is your beta 1, beta 2, and what should be your alpha? You must specify alpha. Alpha is also hyperparameter. Beta 1, beta 2 are also hyperparameters, isn't it? In the case of Adam, there are lots of hyperparameters that we have to look at, especially in deep learning. What is my step number 7? Step number 7 is what is your loss function. If you are using two-class classification problem, it is very simple. Just use simple log loss. If you have k-class classification problem, just use multi-class log loss. For regression problem, what is the loss? Squared loss. Remember, all these loss functions are very easily differentiable. That we already discussed. That is about step number 7. What is my step number 8? Always monitor your gradients and apply things like gradient clipping if it is required, isn't it? This is step number 8. What is step number 9? Plots. Most importantly, you should always plot a couple of plots which are very important, isn't it? The first plot is on x-axis take epochs. Just take epochs on x-axis, and y-axis just take train loss. Ideally, for each epoch, your loss should reduce, isn't it? Like this particular graph. Of course, just like in all machine learning algorithms with train loss, always look for difference between train loss and test loss. The closer they are, the better your model. Means if your train loss is closer to test loss, your model is best model. If train loss is significantly lower than test loss, then you are probably overfitting your. When can I say better model? If a difference between train loss and test loss is very less, if they are approximately same, I can say it's a better model. But if train loss is significantly lower than test loss, then you probably overfitting your model. For monitoring gradients, we can actually look at each of the gradient and see the distribution with distribution of the gradients. We will see some of these examples when we see the code in TensorFlow and Keras in the next chapter. We have to monitor gradients very well. This is step number 9 in monitoring gradients. Step number 9 is plots. What is my step number 8? Step number 8 is monitoring your gradients. We can actually look at each of the gradient and see the distribution with distribution of the gradients. We will see some of these examples when we see the code in TensorFlow and Keras in the next chapter. We have to monitor gradients very well. That's step number 8. My step number 9 is plots. My last step, that is step number 10, is the most important lesson is please avoid overfitting, because it's so easy to overfit in a multi-layer perceptron, especially in deep multi-layer perceptron. And to avoid overfitting, you should always look at difference between train loss and test loss. You have thousands and thousands of weights. It's extremely easy to overfit. So you should be careful not to overfit, isn't it? There are strategies like dropout. There is strategies like dropout to help you to avoid overfit. So these are all the strategies. Even if you miss any one of them, model will go crazy. Means all these 10 strategies, all these 10 steps are very important. I will discuss about all these 10 steps with the proper illustrations in next few lectures. Thank you very much.